So this session is being recorded. And okay, so let's start no. So this is MetE177. But before we start no, I'm just looking at the names at mukhang kilala ko naman mostly kayo no. And some of you even abutan ko nung pre-pandemic no. There are some names na hindi ako quite familiar with. So before we start, pwede ba tayong kahit short introduction na lang para lang ma-remind ako kung sino-sino kayo. And for those na hindi ko nga maalala or hindi ko pa naging estudyante at all, may chance kayo na to introduce yourselves. Okay, so I guess I can start, no? Ako I'm Stan Ehera from UPD ME. I've been teaching for ilan na ba? 7 years na siguro. 8 na pala. 8 years now. And primarily yung research work ko is focused on physical and adaptive metallurgy, no? And itong course natin ngayon, yung MetE177 is actually adaptive metallurgy. Okay? Magtatawag ako tapos kung paano na lang tong listahan na to. Can we start with Sedi? Sedi, you can turn on your camera, Sedi, if you want, or pwede rin ano.
And good afternoon, sir.
Napaka-pogi talaga ni Sedi.
Sir. Mas pogi po kayo. Ayan, I'm Romuel Cedric Acosta. Ayan, currently third year BS Metallurgical Engineering student. And ayan, you can call me Cedi na.
Yeah. Meron ka bang talent, Sedi? Kung nagigitara si Sedi.
Display lang yan, sir.
Ay, display.
Paminsan-minsan lang.
Ay, that's good. Yeah. So thank you, Sedi. Next is si Oyi. Tama ba? Oyi yung nickname mo, Yunel Francis.
Yes po, sir.
Ayun,
Oyi.
Good afternoon. Naalala ko pa si Oyi.
Triple ME14 po. So, name ko po Yunel Francis Malyari. Nickname ko po Oyi. Tapos, third year BS Metallurgical Engineering. Talent. Wala po. Pero minsan po nagigitara.
Ayun, kita rin may gitara din sa background. Ayos yung mga backgrounds ng class. Parang pang streamer. Mukhang gamer din nata si Oy based sa setup niya.
Minsan po.
Sige. Okay, thank you, Oy. Next natin is si Excel. Now si Excel, naalala ko ang pangalan pero hindi ako sure. Baka nasa kabilang class, baka kay Sir Terence siya. Excel?
Hello po. Hi, sir.
Hello.
Ako po si Excel Maria Villanueva, third year BS MetE.
Excel, tama ba kay Sir Terence ka na class? Nag-triple ME14 ka na, di ba?
Opo.
Okay. Kaya parang ngayon lang kita nakita kasi. Okay, may particular talent ka ba, Excel?
Ay, wala po akong talent. Ano lang po.
Kasi ba yun walang talent?
Nag-ano po ako, naggaganchilyo. Pwede po bang talent yun? Kasi hindi naman siya fun ipakita.
Pwede yun. Ganchilyo. Yan yung ano, di ba? Yung, kasi, Bisaya kasi ako kaya hindi ko masyadong, ano yung ganchilyo? Yun yung, ganun yung,
yung may yarn po.
Yun, yung may yarn. Tama pala. Okay, that's good. Excel. Next natin is si Lloyd. Ayun, naalala ko to si Lloyd. Isa to sa favorite students ko eh. Hello Lloyd, kumusta?
Hi sir, okay lang. Hi, I'm Lloyd Nathaniel P. Reyes. You can call me Lloyd. Talent po
Kakanta.
Magtanong po.
Ay, magaling si Lloyd nun. Ito, maganda. Para maganda yung setup ni Lloyd. Parang pang ano yan. Lloyd, pang anong tawag doon? Yung parang bus na may ano?
Wish bus.
Yung wish. Pang wish na ano, na microphone. Kumakanta ka, Lloyd?
Yes. Hindi po. Nahanap ko lang po yung doctor.
Sige. Next natin is si Nico.
Hello po.
Hello. Nico, hindi ko ata naging estudyante pero familiar din yung name.
I'm Faith Nicole Pailona. You can call me Nico po. Ayun, third year BS MetE. Talent po, matulog.
Ang ano si Nico eh.
Dami sa po natugtog.
Tugtog din. Pwede tayong gumawa ng banda pala dito. Parang daming mga rakista ata dito. Ginagamit mo ba yung term na yun, rakista? Uso pa ba yun? Uso pa
Hindi na
siguro.
po masyado.
Hindi na ba? Rakista. Pausoyin natin. Maraming mga rakista dito. Okay. Next natin si Ralph. Nag-estudyante ko nata dito si Ralph eh.
Hello po, sir. Good day po.
Good day,
Ako
Ralph.
po si Ralph Christian Matawaran. You can call me Ralph po.
Parang
Third
pumayat ka,
year.
Ralph ah.
Mukha lang po.
Nag-ano ka ba? Nag-exercise?
Medyo, lang po. Nasa bahay lang po kasi.
Nag-grind ata si Ralph. Daily grind during pandemic.
Sakto lang. Sakto lang po. You can call me Ralph po. Third year BS MetE. Wala po akong talent.
Meron yan. Ano ba? Pico magaling mag-drawing to si Ralph. Tingin ko lang.
Hindi po ako marunong.
Hindi, sumasayaw ata si Ralph para naalala ko.
Hindi po ako sumasayaw. Sir.
Nanonood dati si Ralph ng mga K-pop eh. Sa Triple M. Tama ba?
Oo,
ba yun, Ralph?
dati.
Alam ko nanonood ka
po.
ng ano eh. Yung...
Oo.
Sino yung sikat na ano?
Po.
Sino yung sikat
na?
Yun. Naalala ko.
Oo, medyo.
Okay. Sige, Pico sumasayaw.
Thank you po, sir.
Share naman ng TikTok. TikTok dyan, Ralph.
Di rin po ako nagtitiktok. Wala po akong sockmed.
Ganun.
Facebook
Okay, yan. Sige.
Thank you po.
Okay, Ralph. Next natin si Ray. Ngayon ko lang narinig nakita yung pangalan ni Ray.
Hello,
Ray?
sir.
Hello, good morning. Good morning, good afternoon.
Good afternoon, sir. I am Ray Martin Kiloan Chambal po. You can call me Ray. And I'm a third year BS Metallurgical Engineering student po.
May talent ka ba, Ray?
Mag-scroll po sa Facebook buong araw.
Baka mga memer ata to si Ray. Mga top tier ata yung mga memes.
Pero hobby ko po magbabad sa manga, anime, tapos mga light novels nung manga na yun.
Okay. May
origami. Yeah.
May marirecommend ka bang website na hindi walang ads? Yung ads yung nakakainis eh.
Meron halos puro may ad po yung ko eh. Tapos sa anime naman, anime pahe lang naman yung pinapanooran.
Okay. Sige, mukhang kung lahat ng anime concerns si Ray yung kakausapin natin. Ano bang magandang anime ngayon? Pinapanood ko ngayon yung Fire Force. Maganda kasi animation.
Tama yan, sir.
Yung Fire Force,
yes,
no?
Sir.
Latom. Sige. Salamat, Ray.
Pero ngayon, tinatapos ko yung Jojo. Sige, sir. Thank you po.
Jojo yung yung Adventures of Jojo? Tama ba?
Apa. Yan ba? Yan.
Parati ko nakikita sa memes yun, pero hindi ko actually napapanood pa.
Fun siya, sir. Mahaba lang kaso.
Okay. Thank you, Ray. Next natin
thank you, sir.
Last is si Yusa. Actually, hindi ko alam na MetE pala si Yusa. Nakilala ko lang siya kasi triple M rep siya eh. Yusa.
Hi, sir.
Hello.
MetE.
Ano
po akala yung course ko?
Akala ko MetE ka.
Yeah.
Sige.
MetE, sir. Talent ko, siguro pwede na mag-rap.
Ay, nagra-rap ka, Yusa. Sige nga, sample.
Sir, yung rap lang sa pag karaoke.
Okay. Ganun din. Ako hindi kasi ako kumakanta kaya yung rap din yung yung piniplay ko sa karaoke. Malamang yung forte mo go-to song Stupid Love, tama ba?
Opo, sir.
Yun. Memorize na natin lahat yun. Okay, thank you. Yusa, Yusa, meron ka bang triple M na rep announcement? Baka meron kang dyan i-announce.
Wala naman, sir.
Wala naman. Sige. So, welcome everyone and thank you Yusa. Thank you for sharing. Ah, ano bang gagawin natin ngayon? So, for today, ano muna tayo? Syllabus discussion lang. So, most ng lessons naman natin is ano no, is asynchronous yung method of delivery pero pwede tayong magkaroon ng weekly synchronous sessions para lang ano i-walk through kayo. So mostly yung synchronous sessions ko is not actually a full lecture. Mostly ano lang siya, walk through natin yung mga worksheets na available. Tapos siguro this could be also a forum for ano no, yung feedbacks and concerns sa course kung nahihirapan kayo and parang advising na rin. Okay? So I highly encourage na pumasok tayo sa synchronous session pero if you aren't able to go to the synchronous sessions, pwede namang ano, i-record ko naman yung sessions para pwede yung i-view. And actually meron pa akong meron actually akong mga may YouTube playlist pa ako ng ano no, lahat ng synchronous session from last year. So if ever may na-miss ako, kunwari lang for some reason, hindi ako makapasok at all, pwede mag-send na lang ako ng old videos from the previous from the previous year na in-offer yung MetE177. So let's walk through our syllabus and ito pala yung ovlet natin, yung naka-display is our ovlet class. Hindi ko pa kayo na-add and I'll sync you after this class, no? So, ito yung makikita nyo. So, right now, tatlo pa lang yung available tiles. So, kinokonti-konti lang muna namin para at least hindi siya overwhelming. No? Later on, ipapakita ko yung laman ng yung buong course natin. No? Okay? So, let's start. So, again, this is MetE177. Pwede siguro i-zoom ko na lang. Wait. Okay, so this is MetE177. And MetE177 is Adaptive Metallurgy. Formerly, ito yung MetE147 na course. Okay, it's 3 units. Tapos, its prerequisite is MetE176. And hopefully, lahat naman kayo pumasa sa MetE176 kung pinayagan kayo ng advice. By the way, sino yung advisor nyo sa registration? Si
Hana po.
Ma'am Hana. Okay, si Hana pala. Okay. So, ang prerequisite natin is MetE176. So, MetE176 was physical metallurgy. And if you remember, kung naalala ba yung parang fist-met triangle, no? Na parang, di ba, we can roughly say na yung fist-met triangle natin is divided into 3 parang corners. Tapos yung first is microstructure or internal structure. Tapos yung other corner is the processing. Tapos yung other is yung properties. Tama? Naalala niyo pa yung interrelationship nila? So if you change the internal structure, you change the resulting properties. And this internal structure can be manipulated using different processing techniques. Okay? So yun yung interrelationship nila. Therefore, if you want to improve the performance of a material, kailangan talaga i-consider nyo yung tatlong aspects na yun. So, yung 17 series is actually parang, although in my overlaps, you can see na si 177, you can imagine it as, or si 17 series, para siyang embodiment ng tatlong aspects na yun. So, the first aspect, internal structure, is covered by, mostly covered by 176. So kung napansin nyo sa 176, you go deep talaga into the theories, no? Or yung microstructure theories, yung mga different na atomic movement, diffusion, mga ganun. So parang sobrang lalim sa internal structure yung discussion doon. So yun yung 176 natin, physical metallurgy. Yung MetE11 nyo, formerly 143 yung kinukuha natin to, no? Dati kasi 14 series to. So it's 143, 146, and 147. Yung 143 was elements of material science, pero ngayon ang pinapatake na sa inyo is MetE11, I think. Okay, so si MetE11 focus mostly on properties, no? Parang you have a particular material, kung ano yung magiging behavior na once na ano. So more general siya, no? Although may aspects din of the other fields, no? And dito in-introduce yung MetE1, yung fist-met triangle na yun. Etong last of the series is yung MetE177, adaptive metallurgy. Okay, so we've covered internal structure, na-cover din natin yung properties. Ang kulang na lang is yung processing. So dito, mostly in metallurgical engineering 177, processing yung kina-cover natin dito. So all processes involved in adaptive metallurgy, no? Or most of the processes anyway. Okay, so in adaptive metallurgy, pwede natin siyang i-split into roughly 3 categories, no? And ganun din natin split dito sa syllabus na to. So yung first is yung foundry technology. Foundry is basically casting, no? So that's metal casting. Tapos next is your metal forming techniques, metal forming or metal working. Minsan din tinatawag siyang deformation processing. So ito yung medyo confusing sa ano, no? Kasi if you look at different sources, parang iba-iba yung tawag nila kasi kunwari yung metal forming, minsan yung ibang sources would say metal forming is a casting technique, no? Tapos yung metal working is the deformation processing technique. Pero merong iba na baliktad naman, parang metal forming kasi parang pino-form mo yung metal, dapat yun yung deformation processing. So it gets confusing. So for this course, ang tatawagin na lang natin para mas accurate, gawin na lang natin na yung we'll call the casting as foundry science or casting, pwede rin metal casting. Tapos when we refer to processes like forging, rolling, yung mga ganun, extrusion, we call them as deformation processing because we use the concept of deformation to process our metal. Okay? So mostly pag sinabing deformation processing, ang sinasabi dito is we apply a lot of stress, tapos by applying stresses on key areas, kaya natin ma-shape yung material natin into usable forms. No? Okay? So and I think you're familiar with casting, no? Casting is just you liquefy your metal. Tapos when you liquefy it, you pour it into a mold. The mold contains a cavity that holds the shape or the usable shape na of the final product. Okay, so that's casting. And yung third category natin is we combine this. Ito ay yung metal joining techniques at powder metallurgy. Pero in general, parang dumadami na kasi yung newer techniques, no? So pwede natin itawagin lang tong emerging technologies, no? Okay, emerging technology. So we have powder met is the pinaka mabilis siguro na na growing technology ngayon. So powder met. Meron ng yung additive manufacturing, no, which is yung 3D printing, and meron na actually mga metal 3D printing techniques, pero some of the metal 3D printing techniques actually use concepts of powder metallurgy. So later i-discuss naman natin yan. And also kailangan din natin yung pag-aralan yung yung mga auxiliary processes like metal joining. No? So si metal joining involves yung mga brazing, soldering, welding, etc. Okay? So yun yung rough coverage natin. Ito na alam niyo naman yung mga program student outcomes for BS Metallurgical Engineering students. So you should be able to demonstrate the ability to do all of these things once you graduate the program. But yung sa MetE177, ang ina-address niya is yung etong specific course outcomes na to. So number 1, we should be able to explain metal deformation processing by applying the concepts of stress and state and metal yielding and plasticity. Okay, so this uses a lot of concepts of, sa amin ES13 siya eh. So I think 102 ata nyo to. Ano ba yung deformable bodies? Yung ano ba to? Yung statics of deformable bodies. 101 ba or 102? Yung merong stress strain. May, kung naalala nyo yung Mohr circle. Naalala nyo ba? Yun yung gagamitin nating techniques dito sa class na to. 101 ba siya or 102? 102 yung may stress. 102, okay? Sinasabi na 102. So, you'll be needing a lot of 102 knowledge dito, no? So, Kung naalala niyo yung Tresca criterion, von Mises criterion, or von Mises, yun yung gagamitin natin dito. Okay? So, we use theories of plasticity, metal yielding, yung concept of the stress state para ma-describe natin yung metal deformation processing. No? So, we start off, actually this lesson starts off with the discussion on stress state. No? So, stress state, in ES 102 nyo, usually 2D yung stress state na na inaaral natin, pero we will extend that parang discussion into the 3D stress state. So we will be doing 3 axes, so yung X, Y, and Z, and we'll try to look at yung mga theories regarding yung metal yielding and its effects on plasticity, and how this will translate when we apply it into metal deformation processing techniques. Dito sa course na to, we have 5 metal deformation processing techniques na pag-aaralan. So we have 4 lang pala, sorry. So we have forging, we have rolling, then we have extrusion, tapos we have drawing. So yun yung 4 na pag-aaralan natin. Okay? Then number 2, we will assess the physical metallurgical aspects and considerations involved in foundry and metal forming techniques. So dito, in this course, metal forming is ginagamit natin yung isang definition ng metal forming, which is yung metal casting na. So siguro para hindi na tayo malito, foundry lang yung gamitin natin na term, no. So metal forming kasi is iba pala. Yung metal forming niya dito is for metal deformation processing. So kahit ako nalilito na dito eh. Pero anyway, let's just use metal deformation processing for yung mga involving stress na processes. Tapos pag when it involves melting the metal, we call it foundry and casting. Okay. So number 3, we solve problems on metal forming loads and pressure. So that's deformation processing loads and pressure by implementing knowledge on mechanics of deformable bodies. No? So we apply, ano bang yung ginagamit natin dito? We actually apply yung tinatawag na slab analysis, no? And this is the basis for how we calculate your metal forming loads and pressure. No? There are other techniques. Merong gumagamit ng mga finite element analysis, and this is what makes 177 not an exact science talaga, no? Kasi if you look at it, there are several ways you can compute. And in fact, kung iba-iba yung methods na or calculations na ginamit nyo, pwedeng iba yung resulting na metalworking load. So you could look at one problem, tapos pwedeng iba yung sagot nyo versus sa sagot na makukuha nyo sa internet kunwari. Kasi some universities look at different formulas, no? So kunwari, I think yung mga Indian yung from India na universities, they use another reference, no? Hindi yung So this yung gagamitin nating reference kasi is from si Hosford. Hosford yung main reference natin. Wait lang. Let me use si Hosford pati si Dieter. Itong dalawa to. Ito kasi yung main reference natin, Hosford and Dieter. Or Dieter. Itong dalawang to, they both use slab analysis, no, in their calculations of metalworking loads or metal deformation processing loads. So therefore, baka if you look at internet resources, posibleng iba talaga yung technique na tinuturo. Okay? So, kaya dito napapasok yung parang art aspect ng ng physical, ng adaptive metallurgy. So, it's not purely pure science kumbaga. Okay? So next is yung designing casting riser and gating systems by implementing knowledge on metal solidification behaviors and properties. So dito, when we talk about metal casting, parang we have 2 aspects na kailangan natin i-consider. So number 1 is yung deformation processing. Wait lang. Okay, yun. So, number 1, yung metal, yung riser design. Tapos yung number 2 is yung gating design. So, yun yung 2 aspects ng metal casting na kinoconsider natin. dito sa metal casting dito, heavy tayo on calculations dito, no? And in fact, yung mga calculations na matutunan natin dito sa MetE177, i-apply natin actually sa MetE177.1. Okay? So, in most industries ngayon, gumagamit na sila ng auto or yung computer aided design, no, uh, to do riser and gating systems. And nakalimutan, Magma ata yung sikat na software ngayon. So you can parang pwede mo actually i-simulate kung ano yung solidification behavior ng metal, tapos kaya mo nang i-assess kung meron bang magkakaroon ba siya ng defects or not. Pero right now wala pa tayong technology na yon. So manual method muna tayo. So we'll be using two techniques dito, yung Naval Research Laboratory Method or NRL method, tsaka yung JBK method. So yun yung ginagamit natin para sa riser design. And from the riser design, proceed tayo sa gating design. No? So medyo luma actually yung mga references natin dito sa gating design. It's because hindi actually masyadong nag-improve, no, yung studies. And if you are to do research or kung gusto nyo maggumawa ng thesis or mag-focus dito sa technology nito, actually marami pang room for for further research dito kasi sobrang hindi naman siya young na technology, no, hindi lang talaga na fully developed siya, or hindi, not many scientists actually delved into it, and mostly mga artisans or mga skilled workers lang ang medyo nag-focus dito, no. So parang ang nangyayari is more art lang siya than actual science when it comes to riser and gating designs. And if you'll notice this sa sa industry, when for example merong mga casting, minsan although it's improving, pero minsan parang meron talagang aspect of trial and error lang. Okay? So, if you want to make this as your research topic, it's a medyo mahirap lang kasi you'll have to find you'll be dealing with high temperatures, magme-melt talaga kayo ng metal, tapos it's somewhat dangerous, no, kasi there are risks involved. Pero it's an interesting topic to go into, lalo na pagka kung magma-masters kayo or something, kung magfo-further research pa kayo, pwede actually gawin nyo siyang parang thesis topic to, no? Okay. Next we have ang last natin is to identify the different metal joining technique, powder metallurgy, and other emerging technologies. So I mentioned a bit about this. So metal joining, we usually do yung merong mga adhesive na techniques, meron tayong mga clamping na techniques, yung mechanical techniques, no? Like for example, bolting, yung mga riveting, yung mga ganon. Tapos, pero meron din tayong mga yung mga property inducing na metal joint techniques, like for example, yung soldering, brazing, and welding. So dito i-discuss din natin siya. Then powder metallurgy, ang concept na heavily used dito sa powder metallurgy is diffusion na diffusion theory. So powder metallurgy is diffusion based, no? So you have powders, what you do is you compact them, tapos you expose them to high temperature, and because of the high temperature, the atoms will diffuse and forming microwells, no? And the microwells will hold the shape of the material, forming so it's a very yung powder metallurgy kaya siya emerge fast or quick emerging technology kasi sobrang useful niya. Merong mga shapes kang nagagawa na dati hindi mo magawa. Okay? Tapos mas versatile siya, and it can have unique properties na hindi mo ma-achieve through any other techniques, no? Okay? Tapos yung last na emerging technology, yung 3D printing, no, or yung additive manufacturing. But again, they are related to powder metallurgy, no, kasi most of the 3D printing techniques, ang ginagawa nila, if you're familiar with 3D printing, no, yung may parang head ka. So ginagawa lang kasi doon sa 3D printing is you form your object by embedding layers of powders. Tapos yung layers of powders, kailangan mo pa rin i-sinter yun. And by sintering, powder met technique yung ginagamit doon. Okay? So necessary pa rin na, or yung additive manufacturing, very much related siya sa powder metallurgy technique. Okay? So, ito yung course outline natin. Right now, dapat we'll be doing survey of adaptive metallurgy, no? And this is delivered asynchronously, so you can just look at the modules, tapos do this on your own. This is for ang ginagamit nating module dito as a teaching learning activity is your module 1, Introduction to Adaptive Metallurgy, and it's a reading assignment with some videos that are shown, no? So, ang output natin dito is a mind map that you will be uploading here in Novlet, and it's due on September 24. So it's just a simple lang no activity. I think you can do this in estimate ko mga 1 hour lang magagawa niyo na ito. Okay? So you will differentiate the 4 major categories of metal fabrication techniques, categorize the unit operations and processes in adaptive metallurgy. So it's mostly a survey lang siya. So you just look at resources and try to understand them. Okay? Next natin is which will be on the 24th. And by the way, ito pala yung natin. Pwede tayong mag-schedule ng no. Kasi most of this is asynchronous, pero we can hold synchronous sessions for consultations and parang walkthrough sa natin. Mga worksheets na available, no. So it depends on you guys kung ano yung mas gusto nyo. We can meet every Tuesday or we can meet every Thursday. So I could probably do a poll, no. Poll nga ako. Mahirap dito. Magpo-poll ako sa dito sa natin, MetE177. Para si Polly. I-add ko muna si Polly. So lahat ba kayo na add na dito sa MetE177 Google Chat? So for our course, Google Chat yung gagamitin natin kasi I think if we do Messenger, medyo kasi nagme-merge na yung natin, no, personal life and work life, and we need to strike a work-life balance, no, para maging healthy tayo both physically and mentally. So I think mas okay na hindi tayo mag-messenger as a means of communicating with one another, no, para and napansin ko din to sa sarili kong messenger, no. If I look at my messenger, puro work related na nandun, puro mga group chats about triple M na activities, mga ganyan. So medyo ako nag-expect ako ng sa messenger mga good morning, pero na-receive ko na sana yung ganitong output. So medyo no, stressful siya. So I think para naman natin ma-de-stress natin yung sarili natin, no? Para hindi tayo masyadong na nag-merge na yung work life natin and yung personal life natin. Try natin hiwalay yung dalawang yun. So I created a Google Chat room, and Google Chat is actually quite powerful, no, because we have a subscription. If you're not familiar, si UP kasi has a G Suite. Formerly it's known as G Suite, no, G Suite subscription. Pero ngayon Google Workspace nata, it's rebranded. And one of the perks of Google Workspace is itong Google Chat, no. And Google Chat, I've created a room for us, itong MetE177, and it acts much like para siyang messenger lang din, pero mas powerful in a way kasi pwede siya mag-archive ng mga different files, and you can integrate these files with your Google Drive. Tapos pwede rin tayong mag-assign ng mga tasks, no? So pwede tayong mag-assign ng task dito. So I can assign, for example, task. Tapos assign ko sino ba i-assign ko? Si Oyi. So yun, may assignment ka na Oyi. Tapos kung tapos na ni Oyi, i-check lang niya to. So yun, it's one of the tools na parang upgrade siya from the usual messenger na chat room. Okay? So let's do this. Tapos si Polly kaya pala pumunta ko dito. So let's do a chat. Tapos meron silang mga bots din, no? So yung mga bots dito useful naman. So let's do sync schedule. Gusto niyo ba T or TH? As pasagot na lang ng poll. So while you're answering the poll, continue ko lang yung discussion on the course outline. Okay, so After ng survey of adaptive metallurgy, we proceed with review of physical metallurgy and mechanics of deformable bodies. No, so this is mostly review lang nung yung stress and strain relationship. So hopefully we should be able to explain how plastic deformation influences the mechanical properties of metals, understand yung difference between engineering and engineering stress strain versus yung true stress strain, no, which is an important distinction lalo na pagka we're doing calculations, no. And obviously we also need to interpret the stress strain diagram. So ito medyo review yung dating dito, no, kasi all of this has already been discussed sa MetE176 natin. Okay? So itong particular topic na to is meron siyang module which is module 2, review basic concepts, and yung output niya is a worksheet, no. So yung worksheet 1 will be the review basic concepts, and yung may due date na rin dito na nakalagay naman October 1. And itong worksheet 1, pwedeng ito yung i-walk through natin. So I won't be giving the exact answer, no, pero I can walk you through yung parang process on how you can solve the worksheet, no, doon sa synchronous session natin. Tapos again, pwede rin consultations if may nahihirapan kayong part. Okay? So stress state, ang next na topic is stress state, and it is module 3. And ito sa stress state, mag-discuss tayo ng mga stress tensors, how to calculate principal stresses, and yung directional cosine. So ito, dito na yung first na the first taste of parang mga heavy calculations, no. Although yung calculations naman dito is simple, we can use tools, no, and I highly suggest you download MS Math, no. Wait lang, saan yung mathematics ko? So Microsoft Mathematics, let me MS Math. Ito, meron siyang hindi sa app pala to. Wait. Let me MS Mathematics. Sorry. Microsoft Math 4. Ito si Microsoft Math 4. I highly suggest na i-download nyo to. This is what it looks like. So maganda siya kasi it can do several na calculations, no. Meron siyang it can deal with it can deal with tensors or matrices. Tapos yung some of our calculations actually involve matrix calculations, no. So okay tong tapos kaya din niya mag-deal with mga complicated na equations. So, para siyang Wolfram. Medyo Wolfram siya. But it's offline, no. So medyo okay tong si Microsoft Mathematics. So pwede siguro ipakita in action siya. MS Math. Black lang yung nakikita nyo, no?
Black lang, sir.
Ito yung interface ni MS Math. So you have parang sort of calculator dito. Tapos magta-type kayo ng mga equations dito. So for example, let's just do simple equation. X plus 1 equals 3. Tapos pag in-enter nyo, bibigay niya yung solution. So yan. X equals 2. So ito yung solution steps niya. So parang siya, Wolfram. So I highly suggest na you download this para for all complicated equations, lalo na pagka nag-ano na tayong directional cosines, medyo parang 6 equation, 5 equation, 5 unknowns, parang ganun. So we deal with several na equations. So I think it would be better if you use mga external software, no, para mapabilis yung calculation natin. Okay? So if you have the time, please download MS Math, and pwede i-link ko na lang yung maglalagay ako link doon sa Google Chats na lang natin. Okay. So balik tayo doon sa
Sir,
yes.
tanong ko lang po, para saan po ulit yung Thursday tsaka Tuesday? Kasi di ba po Wednesday, Friday po tayo?
Ay, sorry. Okay, thank you. Akala ko Tuesday. Wednesday ba ngayon?
Yes po. Wednesday, Friday po. Yung schedule natin.
Baguhin natin to at poly. Sync Sked. Or yung sinagot nyo ba dito is Thursday means Friday? Sige, ulitin ko na lang para just to be sure. Thank you, Lloyd. Si Lloyd ba yan? Si Lloyd data yan eh. So yan, pakisagot ulit yung poll. Kung...
Sir Nico po.
Ay, si Nico ba yun? Sorry. Magka-boses kayo ni Lloyd eh. Tsaka nagtatanong si Lloyd eh. Kaya yun yung gusto ko kay Lloyd. Yeah, anyway. Yan. Mayroon ng mga sagot. Mostly Friday. Sige, balikan natin to. Balik tayo sa ano natin course guide. Balikan natin yung poll mamaya. Okay, so sana tayo. So we're done with stress states, and again, mas madali makalculate yung mga stuff dito sa stress state if we do MS Mathematics. No? Okay, so we have worksheet 2. Tapos if you attend the synchronous session, magkakaroon din tayo ng parang walkthrough on how to solve the different problems dito sa stress state. No? And then next, after understanding stress state, so alam na natin kung paano ma-view yung isang stress condition in 3D space. Tapos kaya natin ma-manipulate siya kahit anong orientation na ibigay sa atin. Kaya din natin, from there, kaya din natin mag-compute ng mostly principal stresses yung hinahanap natin. No? So kung naalala yung principal stresses, ito yung stress state kung saan wala kang shear stress, puro normal lang. So it when you present your stress state in that manner kasi napapadali yung equations natin. No? So once you present it in principal stresses, pwede na tayo mag-Tresca and von Mises criteria. No? So the Tresca and von Mises criteria, they are yield criteria, pero meron pa actually other yield criteria. No? And pwede din natin i-discuss yung some of the yield criteria that is available no, sa atin. Okay? So, pero most calculations, Tresca and von Mises lang gamitin natin. So this is the yield criteria is just a criteria that tells us kung ang metal ba ay mag-yield or papasok sa plastic deformation na region given a particular stress state condition. So ang pinaka-simple actually na yield criteria is yung simple na tensile test, yung uniaxial tensile test. So if you look at it, it's actually a form of yield criteria. No? So pwede mong sabihin na if, for example, if you have a stress strain diagram, so meron kang stress strain diagram na, kunwari, just imagine a stress strain diagram. No? Let's see, stress strain. So if we look at a random stress strain diagram, no? So let's look at this, kunwari. Maganda. Pwede natin i-expand. Yan. So, kunwari ito, may stress strain diagram tayo. So, actually, if you look at this, kaya din natin i-predict, no? So, in no manner of speaking, ito, this is actually a yield criteria, no? So, pwede natin sabihin na if wala kasi value to. So, pangit to, pangit. Let's look at yung may values. Sige, anyway, ito na lang, random lang. Kunwari ito, stress state na yung stress strain diagram na to. So pwede natin masabi na if the stress exceeds this particular value, whatever this value is, then we can say that the material will most likely proceed with yielding, no? Or yung magkakaroon siya ng plastic deformation. Papasok siya dito sa plastic region, no? So that is one form of yield criteria, no? Pero this is uniaxial. Again, uniaxial lang kasi siya. So you are only applying stresses in one direction, no? But once you take into consideration yung real world na scenarios which deal with 3D stress states, no? Posible na hindi accurate yung makukuha nating result from the uniaxial na tensile test lang. So we need to consider the other two axes, and those other two axes will give rise to the calculations ng itong yung more complicated na yield criteria, which is yung Tresca criterion and your von Mises criterion. Okay? So knowing those different criterions, we should be able to evaluate the suitability of a metal based on when we talk about failure, no? So for example, if ang definition natin ng failure is yielding, which is in most cases ayaw naman natin mag-yield yung mga material, no? Kasi if it yields, then it doesn't retain its shape, and if it does not retain its shape, it could not function um, the way it's intended to function. So siguro kunwari metal trusses sa isang building. If a metal truss yields, then pwedeng ma-sacrifice yung integrity ng building mo. So we can consider that as a failure, no? Kahit hindi siya nag-fracture, failure pa rin siya. Okay? So we can assess those criteria if we have intimate understanding of yung stress rate, no? So with the stress rate, kung ano na alam natin kung ano yung uh, parang yung tawag dito, kung ano yung work condition or yung actual conditions na na-experience ng metal, kaya natin evaluate kung appropriate ba siya to that particular application. And with that, pwede na ding mag-transition to into kunwari uh, material selection, no? So for example, if you have several materials tapos gusto mong i-decide kung ano yung appropriate, then we can use yield criteria, no? Or yield criteria para i-assess yung suitability na yun. Okay? So maraming practical applications actually itong topic na to. Okay? So we have another worksheet para dito, worksheet number 3. This is for module 4, no? Then next natin is mechanical metallurgy. And we will be giving a short introduction muna. So, fundamentals of hot working and cold working. Tapos, dito walang worksheet. Ito, no? Write-up lang to. So, we'll be doing, actually dito pwede kang hindi na tayo mag-consultation session if you want, no? Or I mean, hindi na tayo magsisynchronous session. Pero as much as possible, okay din na every week nagbi-meet din tayo just in case na merong certain topics kayo nahihirapan. Kahit hindi particularly itong topic na to, kunwari nahihirapan kayo sa von Mises and Tresca, pwede naman pag-usapan din natin siya during the synchronous session. Okay? So, ang output lang dito is a write-up and it will be uploaded in Uvlet, and you should upload it in Uvlet. So next, after the introduction, proceed na tayo sa forging. So itong mga deformation techniques na ituturo dito, itong apat, forging, rolling, drawing, and extrusion, meron siyang two components, no? So yung first component is the parang descriptive component. So papakita yung description of what the process looks like, ano yung applications, mga advantages, disadvantages, tapos ano yung mga limitations. Tapos yung next component niya is a calculation component. Okay? So, yung calculation component, yun yung isi-synchronous session lang natin. So, I'll leave it up to you guys to study on the first component, yung descriptive part. Kayo na bahalang mag-aral nun asynchronously. Tapos, yung sa calculations, yung heavy calculations, doon na tayo magkakaroon ng synchronous session for it. Okay? So, again, yung worksheet, may worksheet din itong each of the forging techniques, deformation processing techniques, meron siyang sariling worksheet, no? So we have worksheet 4, 5, and 6. So you'll notice na si drawing and extrusion is actually bundled together, no? Kasi if you remember, drawing and extrusion, actually parang medyo opposite lang sila to each other, no? So extrusion is you push metal, stock of metal into a die. So you are using parang compressive forces, no? Parang itutulak mo yung metal. Pero yung si drawing naman is instead of pushing the metal, nandun ka naman sa opposite side ng die. Parang hihilain mo yung metal na yun. So mostly applicable ang drawing for wires, no? Tapos extrusion for larger na objects like mga billets. Okay? So pero the concept is fundamentally the same. That's why yung mga calculations nila is actually parang almost the same, no? May konting manipulation lang. Magbabago lang yung mga certain boundary conditions. So, kaya dito, nakakombine sila into one module lang. Or not one module, no, pero one group of topic lang siya. Okay? So, it has two separate modules, module 8 and module 9, pero one worksheet lang siya. Ito. Okay? So, again, ito yung major bulk ng LE1 actually natin kasi after nito long exam 1 na siya, tama ba? Take home exam 1. Okay, take home exam 1 na nga siya. So may reading break tayo from November 2 to November 8. So yung take home exam 1 natin will not include metal casting, no. So ang kasama lang dito is sorry. I think it will include metal casting. Pero itong metal casting na to is mostly ano lang. Naalala ko na. Hindi siya kasama, no. Yung metal casting is hindi kasama sa take home exam 1. Online quiz lang yung meron tayo dito. Okay? Tapos yung to my point, no, yung itong take home exam 1. Si take home exam 1 largely is mostly itong deformation processing techniques, no. Pero meron din aspects on itong stress state and Tresca, kino-combine lang siya into one problem. Tapos hindi itong survey of adaptive metallurgy and itong review of physical metallurgy, hindi na sinasama sa exam, no. Or kung isasama man siya, parang naka-combine na siya dito sa stress state and Tresca and von Mises na problem. Tapos yung most of the calculations will come from itong mechanical metallurgy, no, or deformation processing, wherein you will compute for different rolling loads, drawing loads, extrusion loads, and forging loads and pressures. Okay? So dito sa metal casting natin, hindi pa namin fully na flesh out to ni Sir Jolo, no, kasi dati ang ginawa namin is we usually conduct a we allow students to conduct a parang online forum. So gagawa kayo actually ng parang online event na mag-explain kayo on the different metal casting techniques, no, or the different types of metal casting. Dati nung face-to-face pa to, usually in the form of a presentation lang to, no? So each student or each group of students are assigned topics, tapos magdi-discuss lang sila about their topic. Pero since wala nang face-to-face, ang ginawa namin substitute is yung naggumawa yung previous batch ng ng parang online webinar. Di ko alam kung na-attend yung webinar na yun. Ang title is Angkas Tara Na ata, parang ganun. Something like that. So Angkas Tara Na, tapos doon nila in-explain yung different casting techniques, as may open forum, no. So right now hindi pa namin sure ni Sir Jolo if uulitin namin yun kasi nagkaroon ng problema. Medyo mahirap kasi yung scheduling nun. Tapos may mga students na nagrereklamo na parang mahirap daw yung group activities, no, kasi hindi lahat or most of the time hindi on the same page yung mga students, no, dahil sa limitations like internet connectivity and other limitations. So pwede naming i-reconsider pa tong activity, no. Pero babalikan ko kayo kung ano yung magiging final na activities nyo. Pero kayo, if I were to ask you, okay ba kayo sa group activity if ever? Or would you have any apprehensions? Ano yung stand nyo when it comes to group activity? You can open your mics or parang type in the chat room kung ano yung stand nyo.
Okay lang naman po yung group activity, sir.
Or based sa sa mga previous classes, wala namang issue. Thank you for the feedback, by the way.
Wala naman din po atang issue.
Wala naman. So, sige, isabihan ko si Sir Jolo. Pero if you have any concern about group activities, propose baka medyo nahihiya lang kayong dito sa class. Pwede sigurong i-email nyo lang ako or i-DM nyo ako dun sa Google Chats, tapos para ma-take into account namin yung mga concerns na yun. Pero if we feel na wala namang masyadong concern, baka ituloy natin yung webinar style, yung group activity tapos webinar style yung gagawin nyo. Okay? Take home exam, again, take home exam 1 is on November 17th and it's due on November 19th. So it's a 2-day exam. And obviously open notes siya, no, kasi siya, take home exam. Okay? So next is ito na yung second part ng natin. Second part of the adaptive metallurgy na course. We have the bulk of the calculations, which is itong riser design and yung gating design. So riser design will be using Shvorinov's rule, no? And this is a relationship of your volume to surface area ratio with the solidification time. Tapos ito, we will be calculating the riser dimensions needed for a particular na casting uh, casting product. So we can use either two methods, itong JB Kane, and we can also use the NRL method. Ito yung sinasabi ko kanina. So itong JB Kane actually meron siyang may mga equations dito na complicated, no? So I suggest using MS Math kasi pag gumamit kayo ng MS Math, may mas although kaya naman ng shift solve ng calculator, pero pwede rin gamitin yung sa MS Math kasi at least si MS Math lalo na pag may multiple roots, no? Kaya niyang i-present all of the possible roots. Tapos kasi dito sa riser design may tendency na merong mga roots that make sense, tas may mga roots na hindi nagme-make sense, like for example mga negative roots. And if you know how your calculators work, yung calculators nyo kasi if you if you've done shift solve before, parang siguro napansin nyo na parang before you actually press enter, may tinatanong doon, no, parang uh, question mark ata or something. Hindi niya sinasabi kung basta question mark tapos mag-input ka ng value. Yun actually yung tinatawag na guess value, no. So the way calculators work is parang medyo iterative yung approach kasi niya. So it computes and it approaches a route depending on what the guess value is. So kung hindi nyo, kung diretso enter lang kayo, you're actually inputting a guess value of 0, parang ganun. So the way, ang issue nun is if yung nearest root ng 0, kunwari na guess value is a negative value, then makakuha nyo is yung negative root. So yun yung issue sa paggamit ng calculator lang. So that's why I suggest other more powerful software, no, like MS Mathematics or Wolfram, kasi at least doon pinapakita yung mga all available roots, and based on the available roots medyo kailangan nyo na ng dito, no, engineering judgment. So for example, if you are computing riser design for a, let's just say 10 by 10 by 10 na cube, or let's say 10 by 10 by 50 millimeters na parang slab. Okay? Tapos ang roots na lumabas is a negative root. Tapos may root na lumabas na 12 millimeter. Tapos may root na lumabas na 100 millimeters. Parang ganun. So, you'll have to use engineering judgment. So, kasi kunwari, 10 by 10 by 50 millimeters siya. Tapos ang riser mo is 100 millimeters. That doesn't make sense, no? Kasi sobrang laki ng riser compared to your casting. So kaya doon, kailangan mong piliin yung, or parang engineering judgment would tell you na 12 millimeter yung tamang sagot kasi yun yung nagbe-make sense na route. Okay? So may ganong aspekto. Pero I'll be explaining this in more detail pag pumasok na tayo sa actual calculations. Okay? So that's why preview lang yun. So I highly suggest again na download natin yung MS Mathematics, or kung meron ng parang may nabalitaan ako na meron na daw offline version ng Wolfram na pwede mo i-download. So if you can find that sa mga sites like GitHub, baka nasa GitHub siya, pwede sigurong i-download nyo siya, no? Tapos i-share nyo na lang sa mga kaklase nyo. So if you are able to find those software. Pero right now, ang naalala ko lang is MS, or ang alam ko lang na software is itong MS Math 4. And in fact, medyo luma na kasi na software itong MS Math 4. Medyo buggy siya minsan. Nagka-crash siya actually, no? Tapos, if you look at yung Microsoft na store, hindi mo actually makikita to readily, no? Parang pupunta ka pa sa parang deep sa forums nila para mahanap itong MS Math 4. Okay? So, that's the first part, riser design. So, after riser design, we do gating design. And both are, hindi ko alam kung ano mas mahirap. I think mas mahirap ata yung itong gating design. So based on student feedback, parang mas nahihirapan sila sa gating design kasi mas hindi straightforward siya as compared to yung sa riser design, no? Pero the calculations itself ata sa gating design is easier, I believe. Okay? So ito yung bulk ng calculations ng second long exam natin. Mapupunta sa riser and gating design. Then after nun, that's for metal casting. Then next natin is yung powder metallurgy and other emerging technologies. Okay, so this is module number 13. Reading assignment na siya, some video assignments din. And mostly ano lang to, no? Descriptive lang, wala tayong mga calculations dito sa powder met and other emerging technologies, and ang requirement lang natin is reflection paper, no? And that goes for metal joining as well. Ano lang, reflection paper lang din siya. Okay? So yung last part natin, ito dinagdag kasi because wala actually ano, no, dun sa wala kasing lesson that discusses HSE or yung health, safety, and environmental considerations when it comes to the adaptive metallurgy side. Kasi I think sa extractive tsaka sa MinProc, there are courses that describe yung health and safety and environmental considerations, no? So sa physical and adaptive metallurgy, wala masyado, so we decided na idagdag namin siya. Pero in case lang kukulangin tayo ng time sa SEM, posible na itong itong dalawang lesson, health, safety, environmental considerations, pati yung process control and integration, posibleng i-scrap natin siya. So posibleng hindi siya masasama sa syllabus. Or kung masasama man siya, supplemental materials na lang siya with no, kaya kung napansin nyo, wala siyang actually output, no? So posibleng supplemental materials lang to, just a reading assignment. Okay? So after that, magte-take home exam 2 tayo. So there are only 2 take home exams dito sa sa course na to. And meron tayong last na na problem, which is yung design problem, and the design problem is just yung parang siyang mini preparation siya for your sa plant design nyo. So we will have a mini plant design problem, and this is also group work din at group work din to traditionally, pero again, if you have any concerns with group work, we can probably do individually to. Pero medyo tough task kasi to, madaming kailangan gawin, no? So pag-usapan namin ulit ni Sir Jolo, and we'll talk about it when we have some finality sa mga decisions dito. Okay, pero traditionally, design problems are parang group work siya. And you have a choice between, may 2 design problems kasi tayo. May design problem for metal casting, tapos may design problem for rolling operation. So, parang you have the choice to choose kung alin yung mas gusto nyo. Okay? Okay, mode of delivery natin is asynchronous. Asynchronous yung learning environment, yung university virtual learning environment natin, yung UVLE, yun yung magiging preferred choice of learning management system natin. No? So lahat ng files nandito. So if you look at it, ito siya. So the first 3 topics na naka-upload na, so nandito siya. Tapos nandito na rin yung mga submission bins. And this is not your first time using UVLE, no? Kasi third year na kayo, so I'm assuming you're all familiar with how UVLE works. So naka-tile setup siya, so you could just view UVLE. Tapos merong mga dito. Ito sa class lang ni Sir Jolo, no? Ng WFW. So I'll be probably adding a forum para sa class natin. Tapos doon ko ipopost siguro yung mga recordings natin for the course. I-close ko nga muna to. Okay? So mostly asynchronous tayo, asynchronous learning, and it's your responsibility to keep yourself so to learn at your own pace. So dapat i-practice niyo yung proper time management techniques. Tapos after nun, yun, kaya feel ko kailangan lang talaga ng constant communication tayo, no? Kasi mahirap talaga ang remote learning without without guidance, no? So I highly suggest pasok tayo sa synchronous session, or kung hindi kayo makapasok, you reach out through either Google Chat or email para mapag-usapan natin yung mga difficulties nyo. Okay? So communication plan natin, we'll have synchronous sessions through Zoom, and I'll be magpo-post ako doon sa Google Chat ng recurring meeting na natin. So para pwedeng i-set up ko na tapos every yung result ng natin siya. Dito pala. Every Friday based sa result, no? So we have Friday yung nanalo. So every Friday tayo mag-meet. Okay? So we meet on Fridays, which is good din, no? Kasi Wednesday ata yung kasi baka may iba sa inyo enrolled sa meron bang enrolled sa Friday 177.1 na class? Di naman kayo graduating, no? Ang alam ko yung Friday yung sa graduating class. So, I think it's advantageous for us, no? Kasi para sa Wednesday, yun yung 177.1 nyo. Tapos, sa Friday tayo magle-lecture. Okay? Okay. So, ano pa bang natin? You can contact me through email. Ibibigay ko na lang yung email. Pagka nag-upload ako ng syllabus, babaguhin ko to, no? Ilalagay ko lang yung pangalan ko dito, tapos yung consultation hours, pati email and mobile number ko. So, minsan kasi hindi na ako tumitingin masyado sa phone ko, no? So, baka mas mabilis pa na i-contact nyo ako sa Google Chat kasi nakabukas na yung Google Chat ko dito sa PC ko. So, baka mas mabilis ako mag-respond kung through Google Chat kayo nag-message as opposed to email or SMS, no? Okay? Yung teaching learning strategies natin nakalagay naman lahat. So if you have any difficulty in submitting those activities, just let me know, no? And pwede natin pag-usapan kung pwedeng i-move natin yung deadline for you, lalo na pagka for cases na like for example buong region yun nawala ng kuryente. So we can make considerations for those, no? Tapos highly emphasize ko na we practice the highest forms of intellectual honesty dito sa when we are doing our online requirements, no? Okay? So kahit mahirap siya and because of how the setup is laid out, medyo tempting talaga na to commit intellectual dishonesty. Pero again, you just master the strength to resist intellectual dishonesty, no? So, hindi ko naman kaya, doable naman lahat ng mga requirements natin. And if you need help, just contact me, no? So, I have full trust in you guys na hindi kayo mag-commit ng intellectual dishonesty. But just in case, I'll just be reminded na the department is very active in in filing cases for those scenarios and cases na meron talagang evidences of intellectual dishonesty. So we are able to assess these types of things, no? Kasi with the advent of technology, medyo madali na lang kumbaga i-conduct yung investigation if we feel na merong hints of intellectual dishonesty. So wag na lang natin i-attempt. And again, kung meron kayong urge to copy or cheat, kausapin niyo muna kami. Tapos baka pwede nating pag-usapan kung ano yung pwedeng natin, no? Gawin para ma-reduce yung urge na yun. Okay? Pero syempre hindi niyo naman ako kontakin na, sir, parang gusto ko mag-cheat. Ano pwede kong gawin? Hindi naman. So just approach me na, sir, nahihirapan ako sa ganitong topic. Pwede ba magkaroon tayo ng session para pag-usapan natin kung para matulungan ako, parang ganun. So I can hold online consultations. So pwede naman through chat, kaya naman i-explain siya, no? And if not, synchronous sessions, we take full advantage of the synchronous sessions, so para pag-usapan natin lahat. Okay? Ano ba to? Take-home exams are accomplished individually. So, hindi siya by group. Yung design problems will be accomplished by group. Although, ito, medyo if pa to, no? Kasi, again, may complications nga with doing group activities. Pero, I think, mahirap talaga kung hindi to group activity. So, right now, as it stands, parang group activities i-design problem. Okay, so ito yung magiging breakdown natin of the grades. Formative assessments, which comes from yung practice problems, mga worksheets natin, reflection papers, etc. will comprise 40% of your grade. Take-home exam 1 is 20%. Take-home exam 2 is another 20%. And yung design problem natin is 20%. So yung details nitong design problem, ibibigay na lang namin later on. No? Okay. So transportation table natin, ito, this is the usual na UP grading transportation table, no? Wherein yung uno natin is 92. Anything above 92, 92, or anything above or equal to 92. Tapos yung tres natin is 60%, and every 0.25 step is 4%. Is equivalent to 4% na step up, no? Okay? Tapos anything below 60 will be given a grade of 5. Oh, actually, because of the no fail policy, hindi pala 5. Ida-drop pala kayo pagka less than 60 siya. Okay? So again, I cannot stress this enough. No, it is expected that all of us will exercise and follow the highest principles of academic honesty. No, so any form of work that will be submitted should be your own, not wala kayong pinagkopyahan or wala kayong pinakopya sa work niyo. No? So this is from the UP Draft Code of 2012. So intellectual dishonesty can be defined as any fraudulent act performed by student to achieve academic advantage or gain for oneself or others, including but not definitely not limited to plagiarism, publication, copying of submission of the same work in 2 or more courses. Okay, so merong mga cases no na parang accidental yung plagiarism ng mga estudyante, so it is your responsibility as well to keep yourself knowledgeable of how different academic dishonesty can be committed. No? So I highly suggest plagiarism.org. Pwede ko siguro buksan yun. Plagiarism.org. Ito plagiarism.org is a website. Ito yung mga common ways where you can commit plagiarism. No? So you can read about it. Ito mga what is plagiarism, facts and stats. So preventing plagiarism when writing. So it has a good, this is a good resource para to get you started on keeping yourself knowledgeable on how academic dishonesty can be accidentally committed. No, okay. So I say accidentally kasi feel ko talaga mabait naman kayong mga estudyante, no. Minsan na nakakaligtaan lang, no. Okay. So consultations are highly encouraged. All concentrations via email will be entertained during office hours. Although ako, since medyo nagbago na yung yung sleep schedule natin, pwede kahit hindi 8 to 5. If I'm available, I can reply. If not, right now medyo naging morning person ako, no. So mas active ako sa mga 6 a.m. mga ganun. Tapos minsan nakakatulog na ako ng maaga. So dahil sa pandemic, naging morning person ako. Okay? Ito yung mga text references natin. Ito, some of these references actually available siya sa yung ang tawag dito, yung online na library resources natin. So you can check them out. Pero if not, kung hindi nyo mahanap, and this is off the record, no, pwede sigurong i-search nyo na lang. Kasi you can find ways to find these text references, no. Okay? So kayo na bahala. Hindi ko na tuturuan kayo kung anong website pupuntahan. Alam niyo na siguro yun. Okay, so meron din tayong mga online resources, no. So we have Do It Poems. Do It Poems is from the University of Cambridge, and there are certain mga modules na relevant sa atin, no. We also have itong the Library of Manufacturing.com. So you can access those as well, no. So yun, if there are any changes to the syllabus, which can happen, no, depending on how the SEM goes, we will inform you. And obviously, kasi the syllabus is sort of a contract between the teacher and the student. Any changes we make to the syllabus must be properly, communicated with the student. Tapos we talk about it. Tapos we find a decision that is mutually beneficial for you as students and for us as the teachers, no, para ma-reach natin yung objective for the course. So, meron siguro 224 na pala, no. So we have siguro 5 minutes of Q&A. Meron ba kayong questions about the syllabus? Wala. I see no. Thank you for the feedback kung sino man nag-no nito. Okay. Okay, thank you. So mukhang okay tayo, no? So if there are, kunwari lang, babasahin nyo yung course guide or syllabus natin ulit offline. Tapos may naisip kayong question, huwag kayong mag-hesitate to, to contact me through Google Chat. Tapos i-message nyo lang ako yung specific concern nyo. Tapos pwede natin i-address. Okay? So, i-add ko na kayo ngayon. And I think instant na to ngayon, no? So yun yung maganda sa UVLE integration ngayon. Create ako. MetE177. Let me create course. Tapos show. I will link existing 177. Wait, ano tayo? 1. So, ililink ko siya dito. Sana tama yung ginawa ko. Tama ba? Tama. Okay, that's good. Tapos isisync ko na kayo. Hmm. 11 of 11. Tama ba? Ito nga ba yung course ko? Kayo ba to? Kayo to. So hopefully, makikita nyo na yung course na to, no? You should be able to. But you need to be part of a group to see. Ay, pinaban ako doon. Mukhang nandito na kayo lahat. Nandito na kayo. So yun, try to explore. Actually, meron ng mga other naka-hide pa lang sa inyo. Okay, so try to explore our OVLE course, reread the course guides, tapos you can actually start working on Survey of Adaptive Metallurgy. Meron tong deadline. Bakit wala na yung, meron dapat mga reminders dito. So ibabalik ko yun kasi dapat may isang portion dito that gives you a reminder kung ano yung mga outputs na kailangan or due soon. So ibabalik ko na lang yun para at least makikita nyo kung meron bang certain assignment na due agad. So ito mind map yung pinaka closest assignment that is due. Okay? So I think we can end our session now. Okay na ba tayo? Meron ba tayong other concerns?